In this video, the learner will calculate the sum of the exterior angles of polygons and find the measure of each exterior angle in regular polygons. We've learned from previous lessons that exterior angles are formed when a side of the figure is extended. So for example, in this triangle, we could extend this side and create this exterior angle here, or extend this side and create this exterior angle here, or this exterior angle here. What we want to investigate is what is the sum of these exterior angles. So if I were to take each of these angles and add them together, I could add these up and notice how they go all around one point. That means that each three of these will add up to 360 degrees because they make one whole rotation around a single point. If I took a look at the quadrilateral here and looked at its exterior angles and added all of those up, I've taken each one of these angles and put them again at one single point, and notice they all go around that point to make 360. We could do the same thing with the pentagon and the hexagon, and we would see that they would come together and have a sum of 360 degrees. No matter how many sides the polygon has, the sum of the exterior angles will always be 360 degrees. This is actually from a website called Math is Fun, and it's just to illustrate that same conclusion that we just found. So looking at the pentagon's angles, we have each exterior angle here in the blue. And as I press play here, notice we're making that pentagon smaller and smaller until we see how those exterior angles fit together to make 360 degrees. Each one of those is part of that circle that makes a full 360. Now we want to investigate what the measure of each exterior angle would be for the following regular polygon. So this is a pentagon here. I could find the interior angles first. Because I know it's regular, I know all of them are going to be equal. So through my interior angle formula, I know each one of these angles will be 108. Then I know that these make a linear pair. This interior angle and exterior angle here will be supplementary. So 180 minus 108 gives me 72. But that would mean each one of these exterior angles would be 72, and 72 times 5 happens to be 360. So there are 5 exterior angles, each one is 72, and when I add them all up, of course the sum has to be equal to 360. That leads us to believe we have a formula for that to be each is equal to 360 divided by how many sides there are. So n is still the number of sides. So for any regular polygon, you can just take the total, 360, and divide by n. So for an example here, find the sum of the measures of the exterior angles of a regular undecagon, then find the measure of one exterior angle. If it's an undecagon, we know n is equal to 11. So I have my 11-sided figure here. Each of those exterior angles, when I add them all together, will give me a sum of 360 degrees. For any polygon, the sum is 360 degrees. To find just one of those, I'm going to use that each formula. Each is equal to 360 divided by n. So 360 divided by 11 gives me approximately 32.7 degrees. Here is an example I want you to try on your own. Given a regular nonagon, find the following. Another example I want you to try on your own. Given a regular dodecagon, find each of the following. I also want you to analyze your answers from the previous two examples and find the sum of the answers from parts B and D in each of those, and explain why you get the solution you do. The next example, the measure of an exterior angle of a regular polygon is 30 degrees. Find the number of sides. You're given just one exterior angle and you want to be able to classify the polygon. In this last example, we're given the measure of an interior angle is 144 degrees. Find the number of sides.